All right, hello world. This is CS50 on Twitch. My name is Colton Ogden, and I'm joined once again by
Nick Wong. Hello. That is my name, actually. Sorry, I guess I should start with that. Oh well.
What are we talking about today?
So today we're going to talk about C, not C++, not C#, not Python.
A lot of C languages
C
out there.
Yeah,
but C is like the progenitor.
Yeah, progenitor, I think.
Progenitor. Sort of the old-fashioned one. Very simple, very lightweight programming language. And today
fast as hell.
We're not going to, very fast. We're not going to be talking necessarily about the stuff that we cover in CS50, though, right? We're going to be doing maybe more of a deep dive.
So we will open up GDB, which is the debugger for CS, or sorry, for C. It's for all of CS.
All of CS.
Granddaddy debugger. We're going to walk through a little bit more in depth than CS50 does. Although CS50 does talk about things like malloc and memory spaces and things like that, but I will also kind of be a little bit clearer on like stack versus heap allocation and why one is important, why the other one is not, why any one is important at any one time. We'll talk a little bit about buffer overflows and things like that, as well as how like input-output standard I/O works, because I think that's really cool. So.
And so to low level, a lot of people that are maybe not super familiar with CS might think that means like very basic
Easy,
stuff.
simple. No. That is a great misconception, I think, where a lot of programmers will say low level, high level, and then people are like, oh, I want to learn high level stuff. And generally, that actually seems to be kind of true in the modern day and age. A lot of people do like to learn high level things, but that is not because it's harder or cooler or anything. They kind of refer to, if you imagine a computer system as like at the lowest level, you have hardware, and at the highest level, you might have like a graphic interface, and everything in between is kind of organized. Then that's what people are talking about. So in the lowest level, you have this literal like electrons running around like a piece of metal. If you wanted to kind of vastly oversimplify and humorously oversimplify what's going on, we basically took a rock, tricked it into thinking, and then electrocuted it. And that's the computer, right? Like that is a computer's lowest level. And then right above that, you have this kind of, and there we'll skip a few levels just for the sake of time and clarity, but there's basically like machine code, and we'll kind of approximate that as assembly, which is basically, I'll show a couple examples of what that looks like, but it's the instructions, they're roughly like one-for-one instructions that a processor will execute. And I say roughly because that's not entirely true, but it's the right concept. And then maybe one step up from that, we might have something like C, which is then going to be compiled down into machine code or assembly, and then that will get interpreted in some way. And then maybe above that, you might have something like Python, which actually ends up kind of running on C. I mean, it depends on the runtime you pick, but it could actually be run through C.
Use C to compile sort of the program that executes the Python scripts, basically.
Right, exactly.
Cool,
So,
awesome. Cool. I'm very excited to dig into this stuff because I know C is a very popular language, or has been historically, for game development.
Right.
Assembly before it for the old, to tie back into like our NES stream. The NES was written in 6502 assembly. Very common older microprocessor, still in use for small devices, but not as much as I think more ARM CPUs these days. We have a lot of people in the chat. I just want to shout out everybody who's joined us here in advance. So I guess scrolling way up, we have a lot of chat here. So Twitch, hello world. That's Jax, JP guy, ISO TV. Let me just keep scrolling here. Brenda, Real Curious Kiwi, was in the chat. I see Nonboard. Thank you for joining. Asley, Noanda3333. As always, John 09J Lardenois, thank you very much for joining today. Vipul BHJ and Bavik Knight. Bavik Knight's a long-time regular as well. Let me just make sure I haven't missed anybody else. I think we had LKit57 joined us. I don't recognize that name. I might just have a terrible memory. But I hope I don't have a terrible memory. Thank you very much for joining. If this is your first time, if not, I apologize. Uizuk. Thank you very much for joining. Golden Kappa check. I'm not entirely sure what that means, but I appreciate it. Thank you very much. Oh, we got a lot of Kappas. Maybe they're trying to do like a Kappa test. Make sure the Kappas are working. Okay, Jadlon was talking about in Fogelman craft project. This is like the Minecraft C port, which sort of ties into today's conversation. He's saying he found a really good use for it looks like switch case.
Switch case and break. Nice.
Switch case is a very, very common sort of puzzle piece to use in C.
Yep.
Everybody's hyped. Phones less delay than PCs. That's interesting. higher the level, more abstractions.
Right, that is a great way of putting it, actually.
Yeah, obviously trying to manipulate the silicon directly with electricity is going to be less productive than being able to write a Python script, for example.
Right, exactly.
So different layers of abstraction allow you to do different things more or less easily. Mohala says, what can we do with the C language?
Well, so that's actually a really interesting question in that in talking about any, they're called Turing-complete languages, so basically any programming language you can think of, you can do anything. Anything that you can imagine being done with any language can be done by any of the other ones. So if I can do it in Python, I could also do it in C. I could also do it using only NAND commands. Technically, there is that possibility. So generally what ends up happening is when people say what can we do with a language or what do programmers do in a language, they generally mean a little bit more like what's convenient. So like what things have been written to be really, really good in that language, what things have a bunch of APIs or libraries, what can we, I guess, what has the language been really specialized for? So when someone says that like R, for example, is built for like biostatistics, they mean really that there are a lot of developers who are in bio and do a bunch of biostats who develop for R. And those people are going to be a great community for that. They have a bunch of resources. They'll answer all of your questions on it, all sorts of things. But that is not necessarily going to be like, it's not going to mean that you couldn't in R build like Minecraft, for example. In concept, you could. But whether or not you'd want to is, I mean, I would argue you probably don't want to.
That would probably suck. To see. I would be curious to see how somebody does that.
Or like a neural network in OCaml. You can do it. It would not necessarily be super fun. Whereas in Python, it's pretty convenient. And so there's kind of choices there based on convenience and comfort.
People have done a lot of hard work making libraries and stuff like that too.
Right, exactly.
People that have had an interest in solving these problems who have put that hard work in advance to make it easier for everybody else.
Exactly.
GravyWave123 says buffer overflow.
Yes, we will talk about that actually.
Why is C considered so fast once it is compiled? Wouldn't any compiled language already be compiled into binary, so therefore run with the same speed?
Sure.
Twitch Hello World?
That is a great question. So one of the things is that the developers of the C compiler, of the C compiler, if we're talking about like CC or Clang, then that has been just so thoroughly developed. It's a brilliant compiler, and we'll talk about like compiler flags a little bit today. And I think that there's kind of a funny story dealing with compiler flags and the speller pset in CS50, but basically the builders of that compiler, the architects, designed so many just brilliant techniques for compiling from the C abstract machine down into assembly that ends up abstracting out, or I guess not abstracting out, but cleaning up a lot of your C code once you've written it to make it faster. And one of the other problems that's faced by, maybe you built another compiler and it's just as smart as theirs, except maybe your code is like Python where it's interpreted. So every time I run it, it actually has to interpret the code that is being run and then compile it as it goes. So then that interpretation step actually ends up taking up a bunch of time as well. And there's a couple other reasons that deal a little bit more with how C integrates, or C, C++, C#, kind of all integrate with, I guess integrate's the wrong word. It's not exactly what I'm looking for. Don't have as much overhead in what they do. So for example, Java requires the entire JVM in order to run. And that's a lot more overhead than C, which is literally just executing instructions. So there's all sorts of interesting things there. There's a lot more complexity to that than I will be able to answer, and probably, well, guaranteedly more than I know. But those are some reasons that come up to the top of my head.
Yeah, so abstraction kind of, in a lot of ways, you're paying for performance.
Right.
You know, obviously, electricity flowing through a rock, less performant.
Very fast. You might not understand it, but it's very fast.
Yeah. And to your point about NAND gates, I think I was watching a video recently on Computer File or something where they were talking about how transistors are purely built off of just NAND gates, which I thought was fascinating. They wire them together in like this weird way, and that's all you need to implement
anything.
Oh, that's so fascinating.
NAND on its own is Turing complete.
That is
as a single instruction. For those of you that are maybe not familiar with NAND, it is not of AND. And basically what that means is if I put in a 1 and a 1, then I'm going to get the opposite of what AND of 1 and 1 is, which is 1. So I get the opposite of that, that's 0. And then if I put in a 1 and a 0, or a 0 and a 1, or a 0 and a 0, those are all 0 when I do AND of those combinations. And that is going to be 1. Yeah. So NAND literally only has one case in which it returns 0. The rest it returns 1. And that allows you to do anything a modern computer could do.
That's fascinating.
Which is crazy. Although it can maybe result in millions and millions of lines of code. Because if each line represents one NAND instruction, you have quite a bit going on there.
Yeah, that'd be interesting to see, actually, because I'm not too too deep into that side of CS, but I would like to study more of it. I thought that
it's very theoretical. CS.
Do you ever watch Computer File? Have you watched their videos?
I have not. No.
They have really fascinating.
That's awesome. Are they a YouTube channel?
They're a YouTube channel.
Sweet.
Let me see. Brenda was saying we have 35 new followers since yesterday. Yes, thank you very much, everybody who's followed. And I don't know if I told you, but we have over 1,000 as of 2 days ago. We broke 1,000 followers. So thanks everybody so much. And also thank you to the people who just followed. So Vizix, thank you for following. And Rash KWK, Rasquick. I'm guessing
Rasquick. That makes sense, yeah.
Fquare6. These are some of the people that followed a few hours ago, but just want to shout them out. Taznor, Karan 13421, and Code Blood Rex, Nanomizer, Uizuk, 5 Sharp Boy 3, and Old Forsen LOL. Thank you very much for following.
That's awesome.
So let me just make sure that we're all caught up. I think we're mostly caught up. A lot of people are saying lots of cool stuff. Oh, the golden emote is like a custom. Yeah, golden kappa is a custom emote. I was saying, okay.
Huh. That's sweet.
The real question is, can you build a neural network in Scratch?
I think someone has. I would not be surprised if there's like a student from MIT who was like, you know what? I sat down and I built a neural network in Scratch.
Because they're like, because MIT, you got to rep MIT, you got to do something crazy with Scratch.
Yeah, exactly. And MIT has this whole culture of like building cool things just for the sake of building them. I actually really enjoy I really admire their culture of doing that. I think it's awesome. We have a little bit of a culture here of that, but I think we gear more towards the can I get money out of it, which nothing wrong with that. But I think that I admire the kind of just develop for the sake of development. I think it's very cool.
Moha Last, thank you very much for following. And JP asks, is C a better language to learn in the beginning than C++?
Well, so to ask if a language is better to learn in the beginning depends a lot about your kind of context. So if you have worked a lot with Python and Java, then it might make a lot more sense to start the transition towards C++, because C++ has some of the tools and kind of object-oriented perks of a language like Java or Python, but it is much lower level than either of those languages. However, if you are starting from nothing, CS50 seems to think that C is a great place to start, and I agree. And we'll actually talk a little bit when we get into coding some stuff why I think it's a great language to start with. In particular, I think it helps you think a lot more like a computer. And that tends to be one of the problems with becoming a computer scientist or starting in CS is computers have access to a lot of tools that we don't as human beings. And they think in kind of, I guess, until the singularity, I'm going to not try and personify them too much, but they kind of process things in a way that is very different from ourselves. And it's important as a computer scientist to realize that. And even myself, having studied for a couple of years, I still find myself realizing new ways in which computers process things differently from me. And that's very cool. So I would argue that C is a great place to start. C++ also would work. It does a lot of the same things. But it depends on where you're coming from.
Cool. Yeah, and JP guy says, thanks for clearing that up.
Yeah,
let me just make sure. I don't want us to spend too much time before I actually start diving in. People are saying they recognize computer file. And then Unsigned Ed wants us to go into Bitwise Operators.
Excellent. I'm really glad you asked about that, and we will, because I used to think that was one of the most confusing things that I thought people just wrote just to be confusing. I've actually, when I started in CS, I think I would look at code and think that it was written to be confusing for the sake of being confusing. However, that is not true. There are often a lot of reasons for why people make design choices, and so we will talk about like Bitwise and why it might be really fast or why it might be really useful. It'll deal a lot with how we go into assembly.
Cool. And then Daiguin says, hey guys, I'm a CS student from Rio de Janeiro, Brazil. So thank you very much for joining. Appreciate that. And they're talking, and it looks like they're talking in Portuguese as well. And Drub4 says, hello from Mumbai, India. So
wow, that's awesome.
Worldwide representation. Then Bella Kiers is joining us. Hello, Bella Kiers. Thank you very much. Why don't we dive into some of the topics that we want to take a look at? So I'm going to switch over to our handy dandy computer view screen. Everybody, savor Nick's screensaver.
My favorite screensaver. I think as a tradition now, I'll just open up with this every time. I mean, I'm actually going to be working. Thank you. And I guess the developers of that should say thank you. I'm going to be working in a virtual machine because my own computer does not.
This is Mac OS.
Yeah, this is not Mac OS. This is Ubuntu, the desktop version. And I'm going to work in a virtual machine because I like kind of separating out my C development from my actual computer. And also, it's a little bit more convenient. There's a lot more guides on how to download C stuff onto a virtual machine. I also happen to use this virtual machine for like my systems class, so I happen to have a lot of C tools on it already.
Nice.
And it's super convenient. So that's what we are currently on if you want to, I guess, follow along.
It's a very large, lovely prompt.
Yes, we have quite the prompt going on. I was kind of playing around with it right before the stream because I realized that my prompt was enormous. It was so long because I like to have a lot of information in my prompt, but it's not super useful to you guys, so I killed all that. Now you just have the current directory and an equal sign, greater than sign as my prompt.
And JP is saying that font's nice and big.
Yes, you guys should hopefully be able to read that. If it's too big and we find that it's making things inconvenient, I can always shrink it. But for now, hopefully this works. All right, so in C, we'll talk about makefiles in a little bit, but otherwise we're actually going to start with just raw compilation using CC. And we're going to do all sorts of cool things, but the first thing we're going to do is write our first C file. So I'm going to use Nano as my text editor of choice, and we're going to say, you know what, let's make our, I don't know, we'll call it first.c.
Are you a Nano, or do you use Nano a lot like, for actual development, or are you more of a Vim
Not
user?
usually. I tend to use actually Visual Studio Code for actual dev, but if I'm like kind of typing as I go, then I tend to use Nano very quickly.
Do you use VS Code in your Linux or your Ubuntu?
I do
thing as
actually.
well?
So I have VSC. I can do code dot, and that will open that up for us.
Oh, okay. Nice.
And that helps me kind of when I'm doing any sort of integrated development. And we might actually switch over to that if we need to. Yeah, actually, this might be a good idea. We're going to switch over to VSC so I can keep code open and what's going on. So here we go. We have a new prompt out here. That might be a little bit too small. We'll open things up a little bit. Where is, should be under view. See, the problem is.
That's what I would imagine, but yeah, it's
I don't see it.
everyone's going to have their own settings,
Such a pain.
Locations, and whatnot.
I know. Everyone.
JP is saying, no, use Visual Studio Code, Kappa.
This is Visual Studio Code. Oh, you're talking to,
in
yes.
Vim or Nano.
Yes, yes.
Remember, kids, if you're scared of Google, then your best bet is Microsoft.
Yeah, okay, I can agree with that.
Not worth saying they're a Vi guy. No, use
there we
Vim.
go.
Says on the side.
No, use Vim. So Vim and VI are quite fast, and if you want to be like well respected, I guess, or not well respected, but a lot of coders will kind of prioritize those.
Some of them do give brownie points for Vim users. That's definitely true.
Which, yeah, honestly,
whether that's meritorious
deserved.
or not is up to debate. I think that as long as you're using a tool and doing work with it, I
True.
think that's
As long as you're building
absolutely
things,
fine.
I think
Everybody
it's cool.
has preferences. I'm a VS Code
true.
user myself.
Yeah,
And
great. Yeah, we actually ended up
Were you using
the
VS
same
Code before the games course?
Yes, I actually was.
How long have you been using VS Code?
I started using it, I think, right after someone showed me Sublime, because I was, I switched off of the CS50 IDE, and someone was like, "Oh, you should use Sublime," and then it kept asking me for subscription, and I was like, "Well, this is dumb," and I looked up for like
kind of irritating.
free IDE that's great, and it was like Atom and VSC came up really high. Someone suggested Emacs, which is also super powerful. A lot of my professors use it, but I do not.
People in the Clojure community are in love with
Right.
Emacs.
Yeah, I think it integrates really well with a lot of things.
Yeah, it was written in Lisp, which is the interesting.
Which would make sense. Yeah.
Clojure people probably like it a lot. Anyway,
Yeah,
so
that would explain a lot of that.
Going off on a tangent, I apologize.
No, it's all good. I think that's one of the best parts of these streams. So we have our first C program, and it ends in the .c extension, although technically you could end it in whatever extension you want. And what we're going to do is kind of the characteristic int main void. Oh, man. Boom. And this is technically a C program. This actually will compile just fine. Keyboard shortcuts are a pain. So technically, I can compile this into first, and I'll use first.c. And that compiles just fine. I can even run it. And that's totally reasonable. It does absolutely nothing.
This is stuff that we sort of covered in CS50, just the basic.
Right.
Using a compiler,
Basic
turn the C code into object code -O.
Yeah, exactly. Oh, right. We do actually cover quite a bit in CS50. I don't even know if we're going to touch too much on objects. We might touch on like libraries and things.
Oh, that's true.
I'll focus a little bit more on like data representation and things like that. But yeah, so this is technically a C program. It does literally nothing. But just kind of as a reminder to everyone, this int main void, int main is kind of a very important part of C programs in the sense that you need it in order to run. That's going to be kind of the main thread, for example. So I'm going to import some libraries. Losing my mind. For example, standard IO is, I think, a fantastic library to use, and we're going to talk about it quite a bit. And what we can do is we can also accept command line arguments, so we're going to allow for that. and we'll do *** argv. Oops, I hate doing that. That's a command shortcut from Mac, but I always forget that it doesn't work on this. And now we have access to all of these things. If there is like a variable that you pass in and you don't want to really use it yet, and you kind of want to store it for later, casting to void is a non-trivial operation, but it allows us to kind of ignore this unused variable warning that I will point out in a second. So, oh, well, OK. There should be a warning if I was using compiler warnings. I think -w unused, I can't spell. Unused variable? That might not be correct. Oops. Yeah, oh well. You can pass all sorts of flags to the compiler. There's like hundreds. I don't know all of them off the top of my head, and I don't really use a lot of them off the top of my head. I kind of just use whatever standards are set by the class I'm in. But they are kind of good to know, and we're not going to really play around too much with them. But if you have unused variable warnings, you can always cast a void to ignore them. That's generally a development practice rather than a production one, but something that is, I guess, good to be aware of. So this program that we're going to run at the beginning is, let's say that we want to, I guess we're going to just hop right into it. I want to be able to filter Python files. I'm really annoyed at my developers for writing thousands and thousands of lines of, thousands and thousands of lines of comments, and I want to filter out all of their comments. So what I'm going to do is I'm going to allow us to open up a Python file, and then I'm going to just filter out those lines. And shouldn't be too bad. All I have to really do is include our kind of standard, actually I think standard IO should suffice. So what I'm going to do is we'll just take that first argument from argv, and we will open it as a file descriptor. So file star infile, oops, is equivalent to fopen of argv1, and we are going to kind of add an fclose. Actually, I think it's just, no, fclose works, infile at the end. And what this allows us to do is read from that file. So all I'm going to do is read out the first, we'll say, 8 bytes of that file. So fprintf to standard out, oops, of the first 8 bytes of that file. And this is a reasonable way to do it. And you might go, what's buff? And I will then tell you, yes, of course, great question. Buff is an 8-byte long just array of chars. And what I'm going to do is throw in...
Buff short for buffer, using it as a buffer.
Yes, we're going to use it as a buffer to store whatever we want to deal with. And then I'm going to open, let's see, where do you open the file? And then what I can do is read in, man, I can't remember the name of this. Read, right. Correct. And read, I believe, is source destination. Let me just check that. Cool.
If curious about functions in the C programming language,
yes,
the man word, the man, I guess, program allows you to look them up.
Yes, man is a fantastic program. It allows you to do quick checks like that if you forget which order things are as far as arguments go. And this should be totally fine.
Famous last words.
Yeah, that's never true, but in concept, it's the right idea. So we've now compiled first. And now if I run first, this will break. And, well, I guess not break, but we're not going to really do anything. And that's strange, because I didn't pass in a file, but I'm also not checking for things. And if you took CS50, or if you were following along, then you would know that we actually usually required that you check to make sure that this sort of thing doesn't happen. Accessing argv1 without actually necessarily having one can be kind of weird and undefined and freaky. So what we're going to do is if argc is not equal to 2, one for the file name and one for the actual name of the command being run, then we're going to fprintf to standard error, and we're going to say usage is %s file name, new line.
For people unfamiliar, argc is the number of arguments that you passed in at your program, or that you wrote at the prompt when you executed your program, and argv is an array of strings that represent those individual arguments. Aqualad11874, thank you so much for following.
Where is that file? I think it's actually just from file.io. That's the other thing. It's the read function. I always forget where those all come from. I feel like file.h is maybe not right, but maybe it is. Who knows? We'll find out in a second. Oh, no, that's wrong.
Well, because didn't it compile when you had read?
It did, but it was just being dumb. It's because I'm not passing a lot of the same like with unused variable with like specific warnings flags to the compiler. And so that's where we're going to use Google. Where I don't want to include POSIX, I want to include
now we're back in Mac
file
OS
operators. Yeah, this is Mac OS. C library. And a lot of times these sorts of things, I just forget what they are. Oh, standard I/O, I think, is... No, I thought that's what that was. I thought read was part of standard I/O. In fact, I'm fairly certain it is.
And this is a common lesson, too. Like, you don't need to memorize all of the functions that exist in C. The important thing is that you understand the syntax and how to, like, solve problems. And then you can always Google... Like, modern developers have the luxury of just being able to Google... You know, and also like modern developers are building larger, arguably more sort of complicated systems than they were in the 80s and 90s. Maybe not.
Right, exactly.
It depends on how you define that. But I think definitely using a lot more libraries and having to memorize a lot more functions, I think is probably definitely the case.
Yeah.
So you know, give and take. We have Google, but we also have millions of functions and libraries to sort through, and it's impossible to remember all of them.
Right.
Like, never.
Yeah,
like,
I mean...
Even the ones you use on a daily basis, like what arguments go into this function in what order, doesn't matter as long as you know what the function does and how to use it to solve a problem, right?
Right, exactly. So let's see if we can figure out what's going on here. Actually, I could switch to fread and have that be from standard library. That would be fine.
That's what RASKWK just said, too. Yeah.
Oh, nice.
fread from standard lib.h.
We agree, which is good.
It's like a ESP.
Oh, or not. Oh, what does fread require? This is where things are kind of fun. Oh, I can use that from standard I/O. Oh, I see. So what they have you do, sure. OK, that's fine. So we'll use fread from standard I/O. And what we will do is have that be reading into the buffer from here, 8 bytes of size, or sorry, size 1, 8 bytes. And we'll have that read from infile. And that should be fine for us. fopen is also too few arguments. Right, that is a great point, and I totally neglected it. We're opening things up for reading. I don't remember if it takes a standard.
I see you're used to using single quotes in
yes.
a lot of Python or JavaScript development.
Single characters, and I think it requires a constant char star, so that would be really bad. And now we should be OK on each of those things. And we get a seg fault. And so basically what's going on here is you might go, well, I shouldn't have gotten a seg fault. I caught the error. And then you'll see in the same place where this is what's going on, where we actually should have exited with some error code and then moved on. Right, I keep forgetting which language I'm writing in, as well as where I'm writing things in. Oh, and exit is from standard library. There we go. Now we're all on the same page. A lot of these things I don't necessarily memorize for the same reasons that Colton pointed out. If we were writing in a language that I need to write in consistently for work, then I would naturally memorize most of these things. But otherwise, I'm not going to generally do that.
There's only so much finite short-term memory.
Right, exactly. And so if we were writing in Python, no problem. I can deal with that basically at any time. But if we are actually writing in C, then I think it's kind of just fun to play around and see what's going on. So we now have a functional program, we think. But if we were going to go through here, it would be a decent idea to check that fopen didn't fail. And generally, whenever you're doing these sort of like syscalls and things that are going on, then I would actually be very careful about making sure that a syscall didn't fail. So for example, if fopen fails, we might go into man fopen and see what ends up happening. Sorry, my screen is a little large, but if you go down to the return, man pages have a pretty standard format, so you can actually usually guess at where things go when we get their return value. So upon successful completion, it returns a file pointer. Not a file descriptor, but a file pointer. Otherwise, null is returned, and error no is set to indicate the error. So what we can do is then we can say if not in file, then I want to fprintf to standard error. Sorry. Some sort of error number, or we'll say like error blah, 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 and file not found maybe. And there's actually something really cool you can do there, but we will talk about that in a second. error no, and then we're going to exit. And this might be with a separate error, or I'm going to actually just pass error no. Error no should be set, but we'll find out in a second. Oops. Compile that. Of course, where is error no declared? There are so many ways in which I don't like that. We'll deal with this later then. File could not be opened, and we'll just set error to 2. And then what we can do here is compile it, and now if I try to open a file that doesn't exist, file couldn't be opened, which is good. So let's see, I read in the chat, the duck though says, don't do exit kids, it will not run any deallocation and leak a lot of memory. While that would be a good point, I don't know of any necessarily accurate functions that do automatic deallocation and non-leaking of memory. If you're working in a low-level language, you should make sure to do your own deallocations and non-leakages of memory. In this case, it would be impossible for me to have a leakage of memory in the sense that I never allocated any. At least I didn't manually allocate anything to the heap. So it's not a problem here. There is, if you notice at the very beginning, I went with _exit, which doesn't do any of its own cleanup. And the reasoning for that basically being that I generally, when I'm coding in a low-level language, am expected to do my own cleanup manually, because for courses they don't want you just using library functions that can help clean everything up as you go. So that is what the purpose of that function is. And so it's generally a good idea to be very aware of what exactly is going on when you call any one of these functions. So we're going to talk about that a little bit. We're going to use strace as well to talk about where actual system calls are going. But this startup process is always a pain for me, regardless of when I actually first start writing. And I don't usually write C files completely from scratch like this. I generally actually pull template code that I just store somewhere. So I'm not actually used to this kind of format for doing things. We're actually going to include error no. I forgot that it is a library. And there's a really cool function that I can't remember the name of. And let me see if I can find it, because, and this might seem a little bit ridiculous, but the reasoning for that is that it allows you to describe an error using a string. And I don't remember what that function is called. So we're going to Google that, because welcome to development. Error no string description.
C9221, thank you for following.
Stir error, it's not, oh, that might be what I was looking for. Well, okay, that might be true. We'll try that. We'll see. So this is part of C++ as far as this goes, but it might be part of C. We'll find out. Let's go see. So these are all kind of non, I guess, important, what was that called? Stir error. I feel like that exists. Oh, nope, that's not a library. That's probably an error now. Hopefully it is. If not, I won't spend too much time on it. But it is kind of a cool thing that you have access to and don't have to really deal with on your own. There we go. Sure. Oh, no, that's not what I wanted. You are, has a type int? Really? All right, well, then we're not going to spend too much time on it. There is a function that exists like that, and I apologize for not knowing it off the top of my head. It's there somewhere. That's OK. Oh, that was not what I wanted. There we go. So now I run this. It tells me which error I got, and then we're all good from there.
Error 2.
Yes, error 2, which is what it was set to anyway, but whatever. So now, ignoring that part, I'm going to answer some of the questions that I see upstairs, or not upstairs. In front of me. There we go.
And I've gone back kind of up
there's
to
quite a few questions.
So the peeing horse, which is an excellent name, says people learn the C language when there's Go. That blows my mind. What are your thoughts on that?
So it's interesting because in the C language, you are actually kind of stuck to this whole, you get a specific stack allocation. You can't modify that allocation. You can't take some thread stack and move it to somewhere else in C. You are stuck with whatever stack you're given, because the actual stability of pointers matters a lot. However, in Go, that's not true. You can move things around. It's a garbage collected language, and there's a bunch of stuff that I don't understand about how that works. And you can move that sort of thing around however you'd like. And that's really cool, but I think that starting with C is extremely useful. And technically speaking, if you're talking about which language you want to pick. People will always have kind of their own opinions on where you should start and things like that. My opinion is that starting with something like C is totally reasonable. It teaches you how to think like a computer. It puts you in charge of all of your own memory allocation, and it allows you very low-level access to a computer, which I think if you accomplish all those things, it's a widely used language. There's well-developed support for it, and there's a community that knows exactly what they're talking about that has been around for literally decades. And so I think that all of those attributes make it a really desirable language for learning at the beginning. I also would argue that learning a specific language doesn't necessarily matter. In the sense that as long as you're starting to think like a computer, and as long as you're starting to actually think of things kind of algorithmically and efficiency-wise and as thoroughly as you possibly can, then you are developing the mind of a thought process, or not of a thought process, of a computer scientist.
That's kind of meta.
And that thought process, there you go, yeah. You're developing the thought process of a thought process. You're developing the mind of a computer scientist, and I think that that's what's important.
Yeah, and there's also no reason that they're mutually exclusive. You can learn Go and C, and maybe even use them both at the same time. And I'm sure Go is actually implemented on top of C, or at least, well, maybe.
I don't know. Yeah, I don't actually know.
It could be. I mean, it might
have its own compiler.
Yeah, it could be. It could have its own compiler.
Yeah.
But yeah, I think that religious arguments with languages, I don't think is super productive. People can learn multiple.
Learn all sorts of things.
Yeah, it's good to learn multiple programming languages, different ways of thinking.
Yeah, exactly.
People had some cybersecurity comments as well. Brenda was joking. You don't follow the CS50 style guide.
Right. I believe the CS50 style guide actually does something that I hate, very strongly dislike, which is they do this. Which I detest. However, as a TF, as someone grading things and reading through code, I love that because it is so much easier to read.
Yeah.
However, I used to love it. I now don't really particularly care, and I think this looks cleaner. I think that having like this on its own line is just kind of strange to me. So I generally prefer this style.
This is the original Kernighan and Ritchie style of, mostly because at the time they only could fit like 10 lines of code onto the screen. But so a language that I've been diving into recently is C#. And C# in the C# community, like you are expected to do the
this one?
If you're writing in people's code, like there are certain standards and expectations in the community. If you don't follow those, you're kind of an outlier.
You get kind of pushed in your pride.
It's kind of the same thing in Python. How I used to get scolded for using camel case notation for variable names.
Right. Yeah. No. That's terrible. But if you're coming from like Swift or Objective C.
People were very upset about that. And also shout out to David's in the chat. David J. Malin. Tabs are spaces. Nick says David.
Oh, tabs are spaces. I would thoroughly argue spaces, portability, and and making sure that Python stops yelling at me.
Modern text editors just let you say implement.
Yeah, actually, I was going to point out if you look down in the bottom right where I am currently sitting. We'll see if I can hop out of there. There, where my mouse is and where I was, spaces is set to 4. So all of my tabs actually are spaces. I hit tab out of convenience, but generally, I try to be very consistent and use spaces only.
Yeah, I would hate having to type 4 spaces every line that I want, or 8 spaces or 12 spaces.
Right, exactly. Yeah, it's a huge pain.
Tabs that are implemented as spaces are definitely the way to go.
Yeah, I'm a huge fan of that.
Let me make sure we didn't miss any other key comments up above. JP saying they don't develop in C, even though they spend a lot of time here. I mean, we don't really spend a lot of time in doing C on the stream. I mean, obviously CS50 teaches C, but as kind of a learning point, and they sort of let you jump off into Python, JavaScript, other languages that are actually more in vogue, I think, for most developers these days. Aqualad 11874, thanks for streaming. Awesome, thanks so much, Aqualad, for joining us, and thank you for the follow earlier.
Yeah.
People were helping you debug live. UniSTD.h.
Always appreciate it.
Was Brenda said. I'm not sure what that might have been a reference to.
There's all sorts of cool libraries for things. I tend to stick to very simple, very minimal libraries. And I say minimal. Standard lib is huge. What I basically mean by that is I stick to things that are as simple as I can find them, or as close or low level as I can find them. And generally the reason for that is that I want to be very consistent in how I actually end up developing any piece of C code. I also try not to include libraries if I don't have to. And people would argue that there's like efficiency purposes to that and things like that. That's true with a caveat. But it's more important to me as like a coder that I don't include a bunch of fluff everywhere that people don't need to read through, or that makes it harder for you to process where things came from. And for debugging purposes, if I include like 10 different libraries, I might not necessarily know where any one function came from, and it's easier for me to just keep in my mind what's going on. And especially since you guys are getting kind of a live version of how coding works here, you basically are seeing a little bit of how my development process works, which is very it tends to be very Occam's razor.
Very Google-oriented?
It tends to also be very Google-oriented. And I saw someone asked, what was the question? Someone asked which programming language, or did I learn a single programming language for technical interviews? And the answer is, I actually learned programming languages because I thought building things was cool. My focus at the very beginning, I didn't even know what a technical interview was. I had no clue. I just knew you somehow could end up working at big tech companies or whatever that was. But I just thought it was really cool. I liked building tools for varying things. And so I kind of accidentally learned a lot of languages. I learned a lot of them through my classes. I learned a lot of them just by like wanting to build X and knowing that I needed to hop through learning this language to get there. But the language itself was usually not my goal. I actually don't have a single language yet that I've learned as like for the sake of learning that language. However, I think this winter break that might change.
Which language?
I think I might actually learn Go for the specific reason of thinking that it's a very cool language, very new age.
It's apt because you're going to work at Google, so I mean, I feel like
right. I think that would make sense. And so I think that's probably something that'll change a little bit. But in general, that's still going to be very project-oriented. I think that it's a little bit easier to motivate yourself if you have project-oriented things going on in your mind. And so also something that's interesting about technical interviews is at a lot of companies that I've interviewed at, I haven't really needed to code in a specific language. With startups, that's a little different. But with like big tech companies,
startups have more of a specific stack that they're looking at.
Right, exactly. They're like, I want people who can do this because that's what our team is currently working on.
Right,
and
it's
want
fairly
like
small,
Python,
it's fairly focused. It's not as wide-reaching
exactly.
as like Google obviously has a million different things.
Right, you could go develop with anything. And so I think generally speaking, I will learn I learn languages because you do need them to write actual code. You can't write in pseudocode. Well, Python basically, but like you can't otherwise do that. Yeah, and I love Python. I use it all the time.
Python's a great language.
It's great.
I love Python.
But I generally, like, in a lot of technical interviews, I kind of write in like a blend of languages. Like there's certain things that are really convenient in C, so I might talk about them. And there's certain things that are really convenient in Python, so I might kind of like ping something towards Python. The funny thing is, like, if you look at my like whiteboarded interviews, I'm pretty sure I like every other line have a semicolon at the end of the end of the line, and like you're not sure.
Hard.
Yeah, it's like I don't know where that language came from. That's from C, C++, and Java, and so it's very interesting. But someone also, while we're on the topic of technical interviews, asked, can you look up these libraries during your technical coding interviews? No, not usually, at least not in like in-person interviews. And I would also recommend not really doing that. You don't really need to, because I think that you can. In an interview I had, I said, well, there's a library that does this. I know it exists. I don't know the exact syntax, but I'm going to write it like I do, and you'll understand what I mean. I'll use clear syntax and clear things in order to indicate to you, my interviewer, what I'm trying to do, because the interesting part is solving this problem. That's what I'm after. That's what you're after. And you have 4 interviews today. Hopefully this one will be interesting, because I want to solve the problem. I don't need to focus on, is it a library that's capitalized or not? Who cares? I can go Google that. And so generally what I would do there is I'll say, we're going to just call the library, let's say I forgot malloc, which that might be kind of a red flag, but like, we'll pretend that's not. And I say, we're going to call it the Allocator Library. And I'll say, here's the syntax for it in concept. It has some sort of allocate, it has some sort of reallocate, and it has some sort of delete. And so that's kind of a weird mixture as far as like syntax goes. Of like a purist would say, well, you're blending C, C++, and like some weird version of Python, and that's fine. I'm still hitting the concepts. I'm showing and demonstrating that I understand. What does it mean to have something allocated on the heap? Things like that I think are really useful. I think those concepts are much more useful than actually memorizing all of those things. Twitch Hello World says that that's interesting. I have to be super exact and technical in interviews in my area, though. Only for teaching interviews do I get asked to actually do something similar to a coding interview. Yeah, my pleasure. They said thanks, and I said yes.
Hong Yi and Imagine a Wave, thank you very much for following us.
Yeah, awesome.
Let me just see. We have a lot of people. So Irene and Andre, I noticed during the chat, the duck, though. I think we saw the duck, though, earlier. Do you still use the auto and register keywords for C50? I'm not sure if. For C. Oh, that's for C++. Newer C++.
Yes.
fcontrol.h. Steve Ronix made a point. I'm not entirely sure what library that is.
Yeah.
Using libraries is for the weak.
And I think we kind of hit on something similar in the last maybe 2 streams ago, where it was like, if I built everything myself, would I be secure? And I'd argue no. And so, I mean, that's kind of interesting. But yes, using libraries is for the weak. I count myself amongst the weak. I also sleep, which is for the weak.
Why exit instead of return? Asked Brenda.
Right. So I deal, basically that just comes from an old habit of mine where I am actually in the process of completing a bunch of p-sets where we were dealing with like process forking and threading. And so I was using exit from those p-sets, and I just kind of got into that habit. There's not necessarily a huge distinction in this particular case because we have a single thread, we have only the main thread, and exiting from it as well as returning from it achieve roughly the same goal in that they both end the function. A return is going to it's going to return whatever that number integer you have out to I guess the kind of error return here, this, and it'll deal with a lot of just kind of what process cleanup has. I like exit. It does do some of its own cleanup. It deals with a little bit of like marking a process as dead and getting it killed and things like that. But in this case, I don't think it actually really matters too much. And for our purposes, it certainly does not matter.
All right, cool. Let me just make sure. There's so much chat. There's
we really appreciate you guys participating.
It's amazing. We're super happy. I feel horrible that we haven't been able to read off every message at this point. And Annie was saying C++ isn't the allocate memory for you either, which is correct. Fatma, hello. Thank you for joining. Hey, Chad, have you what are the benefits of using float instead of double, which allows for higher precision? Just the memory usage, as President of Mars?
So there can be a bunch of reasons for using a float instead of a double or vice versa. Generally speaking, I will argue for using as little memory as possible and as simple as possible. So if you're talking about some sort of float, then we're dealing with a fairly large amount of memory relative to like an int or a char. If you're talking about a double, then you're similarly in a boat where you're using quite a bit of memory relative to an int or char. And I actually generally don't really use float or double. I mean, that's a weird statement.
I don't use floating point mount.
Yeah, like it's a weird
Integers
thing to say. Just all integers. And I think that there are, I guess, just use cases in which either one is useful. Sometimes it deals a little bit more with like which platform you're on, but even then, in the modern day and age, that's not really true. I can't think of a use case right now. If I think of one when I get there, I will let you know. I think it's a good question that broadens to kind of why do any one practice over others. So like, for example, why would I stick to using integers and chars? Integers don't cover enough numbers, and chars are only one byte. Oops. But for example, we're going to talk about how one of the powers of C and low-level languages in general is I get direct access to memory, and I can think of it as kind of like a raw block. It doesn't have any shape. It doesn't have anything that it really does on its own, and I can reshape that block however I'd like, which can be really useful. So that can be really interesting to do, and we'll get there in probably a couple minutes.
Thank you very much, Dwayne Yacer, for joining us. I know that, I don't know if I've seen it, or which environment I saw it in recently, but depending on whether you have a 64 or 32-bit processor, doubles are actually more efficient than floats because they're typically 64 bits. So they're the word size of the machine, so it can be loaded in one CPU call. And I forget whether it was in, I think it applies both to the context of C, C++, and also VM platforms like the CLR and Java, JVM. They're able to just more, especially if you're doing like a lot of double operations in a tight loop.
Right.
Loading that double into your register and then being able to do it. Yeah. That's the only context that I'm aware of, besides the fact that you just get more precision with the double, where you can actually get performance costs out of it. But to your point, I don't think for a lot of use cases that's going to necessarily matter. I think it's really for really intense stuff, like game engines, for example.
Right, which those come up a lot. Yeah. I mean, game developers have to deal with a lot of things like that. It actually matters. All right, cool. C has not a garbage collector. You're right. C does not have a garbage collector. C has very little, actually.
Yeah, C is a very lightweight program.
It's pretty limited. Yeah.
There are amazing libraries that people.
Exactly.
Does Newt compute from one religious debate to another? That's been the theme today so far. Everybody was shouting out David. David asked about the tabs question. Pascal case says code editor. Feels good, man.
Oh.
Yeah. It's great in C, in C++, but you go to Python and people
people
vomit.
lose their
Instant vomit.
They just can't deal. I can barely deal with it. I think in my C programs I write in underscores.
The duck though says, ew, C#. I actually like, if you're comparing to Java, I actually like C# quite a bit.
Yeah, I would agree with that.
I tend to prefer coding in Python over C#. But C# I actually enjoy. I use it in Unity development. It's actually a pretty nice language. It's got a lot of cool features. And they're consistently adding new stuff to it like every other year, which is great.
Yeah, that's true.
Tabs are converted to spaces, aren't they, Bavik Knight, in the context of text editors? Yes.
Yeah, they can be. You kind of have to be careful about that. Python will catch you on it if you're switching through things. I'm sure a bunch of other languages, interpreters will catch you on that.
Yeah, if you're doing just raw, like a raw text editor or something, and you're using tabs versus spaces, it's not going to know the difference. It's going to know the difference. I mean,
right.
to say.
They'll pick up on that.
Okay. Thank you all from the low-level programmer, says Hinalar. Thank you very much for joining us. People want to fight religious debates.
People are, every time you bring up like this sort of thing, once you get into like C or C++, or actually any programming language, I guess, people will always have their own opinions on like what libraries you should use or shouldn't use. I'm generally pretty lax about that. The times that I would not be are when they affect memory or efficiency, or they have some known bug that I'm aware of. But otherwise, if it gets the job done and it does not violate any immediate practice that I know of, then I see no problem.
Enough boring C. Let's do inline assembly. Though.
Inline assembly. Yeah, I don't really want to write assembly.
That's some 90s programming right there.
Yeah.
Nuanda333 Asley says, what's the best thing you've built so far?
Oh, that is a great question. I have built lots of cool things. Sorry, that sounded very arrogant. That was not intended that way. I think I tend to detach myself from the things that I build and just kind of look at them as their own objects and think that they're kind of cool. So I spent a lot of time developing a auto-grading software for a club that I run here. There's some labs that I've built for a cybersecurity club here that I think are very cool. I built my own version of a VPN. Originally it was based on OpenVPN, and then I kind of modified that and tweaked it. So I guess I would say I kind of like stood on the shoulders of giants there, but I thought that was really cool. I built I leveraged a Raspberry Pi Zero, so very small, and built or designed a device that allows you to plug it into a computer through USB, and it can simulate basically any kind of connection or hardware device that you'd like. So you can kind of pick through the Raspberry Pi's interface, which it generates its own Wi-Fi network when it has power, and you can connect to it through, I built an app for it on my phone, or you can just connect to it via the Wi-Fi interface. And what that lets you do is you can pick what you would like to simulate. So you can simulate like an Ethernet connection, you can simulate a keyboard connection, or even a mouse connection if you'd like. And I found that the keyboard and the Ethernet interface are the most useful, in that what I can do is then if I'm simulating a keyboard, then I can actually brute force like the password to your computer, which is kind of cool. I think that's I think that's awesome. I would never use it. I have no need to, but I think that's awesome. I think that's just a really cool thing to be able to do. If you simulate an Ethernet connection, then what you can actually do is, I guess, pretend that this is now the internet. You can set yourself as like the highest priority Ethernet connection, and then your computer will send out connections because it's listening for and asking for like site updates and things, even when your computer screen is locked. So I can kind of bypass your password in that way and maybe poison a bunch of your browsers. And then when you log back in, they are all like messed up, and they will reach out to me instead of where they're supposed to go.
For the win.
Right. All white hat. I actually am very, very solidly against hacking for personal gain. I think that is awful. So there's all sorts of, I guess, ethical debates and qualms that I have, or maybe not qualms. I very thoroughly am against people who hack for personal gain. I think that would be awful. Based on the sense that I think hacking in computer science, and in general I have a pretty positive view of humanity, should all be used to help people in general and help the community, help the world as a whole. So yeah,
it seems to be the case that just by knowing how it works, you have the best defense against that.
Right. Also true.
That thing that you hate so much, you find a way to combat it. I think more appropriately. And they're saying, shout out for Google's future CEO, Nick.
I appreciate it.
Okay, we have done a ton of comment reading. We'll pause here. I'll come back on the comment reading. Let's go to the next, I think, sort of C coding.
Yeah, we'll keep going. So we have now kind of checked our file descriptors and things, or I guess we've checked that we have the right number of arguments. We have checked that we have an actual file that has been opened, and then we set up a buffer, we read into that buffer, and we print into standard out from that buffer. So one of the kind of cool things that you can, oh, whoops, not what I wanted. Make sure that that's up to date. And then what I can do is read in itself, actually. And that broke, which is great. Oh, whoops. I gave it 3 arguments because I can't read. And we get the first 8 bytes from our own file, which is kind of interesting. So what this allows us to do is I can set this, we might say like some int n is actually a little bit more general here. And we'll have n, and we're copying in n bytes. And what I can do is then recompile this and run this. And I get that, which is kind of interesting.
Apologize also, I missed Schick. Followed us at the same time that Dwayne used to do. So thank you very much, Schick, for following.
Awesome. And so you get these kind of like weird characters that my terminal doesn't know how to interpret and just kind of like throws its hands up and gives up. But generally, I have now been able to, oh, whoops, that's not what I wanted. I can copy up to 64 bytes of my file, my input file. And I can do that with any file, really. I could even go to like my desktop, and I don't know what's in my desktop, but sure, we'll do our like bash history. Oh, that's a bummer. So it couldn't actually open that file, which is a shame. Oh, .bash history is probably why, but there you go. And so you get the first 64 bytes of that. So we're doing something very simple. We're just opening a file, reading out the first 64 bytes, reading it into a buffer, which might cause people to think, oh, this is terrible. But that's OK. We're going to kind of ignore that problem for now. But what we could do, after we have started to open files and everything, is maybe we want to be able to read in the whole file and then print it out in buffered chunks. And that would be a very reasonable thing to do. So what we're going to do is while, and you might notice there's an unused value here. Technically what I could have done is this, and if I had better warnings set up, then I would have gotten a warning on the fact that fread returns a value that I'm ignoring. But we're going to kind of ignore that for now and pretend that it doesn't matter. I don't know why I started typing up here. I'm losing my mind. And so what we can do is while fread of buff1 n in file is not equal to, I believe it returns 0 at end of file. We'll find out. Then what we can do is print out that buffer. And what this, in concept, if I'm not losing my mind, which we all know that's not true, that should allow us to read in the entire file, and basically first is going to have a different name now. We're going to call it cat. And /cat of first.c should read out, it's pretty close. We were reading out some junk. We shouldn't necessarily be doing it that way, but that's OK. So this is roughly the right concept. Oh, there's a bunch of those. Oh, OK, that kind of makes sense. Does that make sense? Let me think about that for a second. There shouldn't necessarily be junk there.
Because there are those semicolons. Are those semicolons? What are
it looks like they are all. I don't know. Let's see if we can figure out what those characters are. So under.
No, they're not semicolons because there's a semicolon there in the.
Yeah, there's kind of an interesting character going on there.
I think you've been hacked.
Yeah, I've been hacked by magic.
Clang.
Yeah, that's an interesting character. My guess is that deals with junk that is not the Null Terminator, would be my guess. But we'll find out in maybe never. But that does roughly cat our file out. I also know that this terminal has some bugginess where, like, if I type underscores, they don't always show up. Like I think echo __. Oh, just kidding. OK, so who knows?
Does your normal shell work? Well, no, not the integrated one in VS Code, but the one that's in your actual terminal?
We can find out. Let's see. That is a great question. Oh, well, you get that. Let's see. Where is everything? .cat first.c. Oh, no, it's even weirder.
OK.
Interesting. My guess is that there is some junk sitting in the buffer, and I'm not clearing it. I don't actually zero the buffer. And so that might be something to look at, is like what happens if we fprintf. Oops. I love that we always, it's a perpetual sidetrack.
It's a good life.
It's it's like a very cool, I think, thing to be able to do. This actually should, well, no, it won't segfault. That is OK. It's OK to type. So now if I do first, actually, let me also txt.
I was about to say, do you want to like write a test script for?
Yeah. And then we can run this test.txt. And OK, cool. So it ends up actually being OK as far as that goes. My guess is that at the end, we are encountering stuff where it's not reading exactly, because our buffer is 64. So let's say I read in 1024
bytes.
bytes.
More than the number of bytes that are in the file.
Yeah,
it's
my guess
to
is
read,
it's doing something
because there's
weird.
not 64 characters in that text file.
Right, exactly. So it's doing something kind of strange
It's
with
just
that.
reading.
Sure,
Yeah,
that's
okay.
fine. And so if I was smart and if I wanted to actually like thoroughly debug this, then what I would say is we should be very careful about making sure that buff gets set to 0 after you've printed everything out. So like you could do buff is equivalent to like null byte or something. 0 would actually probably work at the end. Actually, what I would do is something like this, memcopy. I don't remember how exactly memcopy works. I believe it's memcopy. Well, let's see if it. Visual Studio, tell me. I was really hoping it would. So we can
I think you can
memcopy.
get that to happen if you install the right extension.
I know. I really should spend more time installing the right extensions on these. Destination, and we'll say source size n.
Hi-Fi CS, thank you very much for joining.
Actually, we could just, oh yeah, actually, that's fine. Constant void star, we'll do null byte. And let's see what that ends up doing. Oh, that's not good. Oh, string.h, good to know. And this is, I actually generally prefer, generally I prefer knowing which libraries I need. But if I don't, then I would much rather be told what to do there. Null argument where non-null is required. Oh, that's a bummer. Where am I doing that? What is the non-null argument?
Does it consider? It doesn't consider the null terminator character to be null, does it?
I don't think so. Oh, maybe it does. Because there's only 3 arguments required. Oh, that's kind of cool. So what we could do, maybe that's just, actually, what I could do is just null. See what that does. We'll find out. Well, that's even worse, but maybe it'll work anyway. Get some, yeah, there we go. Get some even worse behavior.
Safe.
Yeah, very, very bad. So if I wanted to, I could play around with this and debug it, and we'd be fine. I am pretty confident in saying that like it's just junk at the end of the buffer.
Ducto is saying memset buff 0 and then size of buff.
Memset is a much more useful command there that we could use. Yeah, there we go. So that's gross. We'll do 40 or 64. And then, oh, well, another thing to consider is that each of these buffers does not have a null terminator at the end. And so that might be causing some of this problem. We can do that here. Memset, did he use the actual syntax for memset? We'll see.
Yeah, it was
buff 0 n
buff,
probably.
Buff, comma, 0, comma, size of buff.
Cool, that works.
Which n in your case would be size of buff.
Cool. My intuition is going to say that that deals with my null terminator.
Meowcat, C is hard.
Yeah, no, it's a pain. Yeah, and that is what I will say is true, in that the null terminator is not going on here. So what you could maybe do is set this equal to the. Actually, yeah, we're not going to deal with that too much because it isn't necessarily the main point of the stream. But what I might recommend is setting everything to, what do you call it, null terminator, and then then proceed with the way that we're actually doing it here, and that should be fine. Basically, just copy n up to negative n-1.
Brenda was asking, can you just 0 out buff before you read into it?
We should, well, so actually I believe what's missing here is our null terminator, because you could do something like this, and I believe we'll end up with the same behavior. Ah, crap. Whoa, that's a bummer. No, there aren't. Yes, there are. I'm a huge fan of blaming the compiler until I realize what I did wrong, and then I stop blaming the compiler. I don't inherently see what's wrong with that, but because okay, sure. We could do this then, where you memset all of buff 0 to n, and I don't I think we'll see the same behavior. We can find out. Yeah, we'll end up with the same behavior. And that's fine. My very strong guess is Null Terminator dealing out here. And it's OK. We don't really have to deal with it inherently, but maybe it's something to kind of keep in mind.
Cool.
Cool. So after we've kind of dealt with all of those things, we now have something that allows us to code kind of line by line. Well, ish. It allows us to take in buffers and things and allows us to kind of go through our file one buffer length at a time. However, it might be really reasonable to us to...
Oh, you're not even saying your buffer size n, you're reading n bytes, you don't have any room for the Null Terminator.
Correct. So what I would recommend doing is reading in n-1 bytes and setting the initial thing to the Null Terminator, or all of it as to null. And that should actually end up being OK. So you could do something like this, actually, which I believe would work. Yep.
Wow.
Now, there is a slight problem with that, but that's OK. Basically, the problem being that I have appended this whack n. And so what you can do is here. And now we're good. Thank you. I thought about it and then didn't do it because I thought it wasn't worthwhile.
It's always like super helpful. She helped me debug something that I was doing on stream too at one point. A physics-related thing in Unity, and I was like, what is going on right now?
It's one of those things where, like, if you're doing it on your own, never a problem.
Yeah.
You'll never face that problem. But the second you do it in front of someone,
when you're doing it in front of somebody or a lot of people.
Yes, if you're ever doing it in front of a lot of people, they will immediately notice, and your mind will lose itself, and nothing will ever work. So thank you, appreciate it. But now we might want to do something a little bit different. We might want to read actual line by lines. I see someone, I think MyOwcat, IDK what he is doing, looks like trial and error, and you are very much correct. That is a lot of what this is, because we do code live, so we don't actually prep anything as much as I would love to. Generally when I do some sort of like seminar or I guess lecture or general like educational tutorial, I like to prep like an entire script beforehand. I like to prep a bunch of code, and I like to basically not have to really worry about coding in front of people. However, in these streams, we found that it's really cool to be able to kind of show that we're fallible too, and we make all sorts of mistakes. And I'm actually very comfortable making mistakes in front of people. I do it constantly. That's just my life. It's just making mistakes after mistakes.
Same. I've gotten used to it too for the streams that I do.
Exactly.
It's okay.
And it's
the nice
totally
thing about
reasonable.
it, it's very flexible. We can go into, because if you're adhering to a script,
right,
and we want to like talk about some other random topic, and you veer from your script, you can screw yourself up big time.
Exactly. So I like this actually quite a bit, and I don't necessarily have any major problem with that.
We all make those mistakes. Yes, we do.
Yeah,
yes,
exactly.
Okay, yeah, no.
No, we're not insultable. Trust me, we are pretty much not insultable, I think.
I think so, yeah.
We've been through plenty, and you're all good. We've been on the internet before. And I mean, I actually stream video games from time to time, and people are much worse. Like, I mean, you guys are super nice. You guys had the chance to hack our WordPress website last time, and did not put like porn on the WordPress website. Like, you know, like, you guys are fantastic.
It could have been much worse.
It could have been so much worse. We really appreciate the way you guys actually interact with us.
Now, it would have been hilarious, and probably a meme. It probably would have become a meme.
We would have had to just cut it out.
It would have been, people would have clipped it, though. People would have clipped it.
Exactly. Our editors, I think, would have cut that one out. So, yeah, no worry. You will very rarely offend us. I would argue probably never. It would take quite a bit. That's not a challenge. Like, keep doing what you're doing. That's good.
Cat's asking, what's your Twitch stream?
So it's Powerhouse of Decel. It's a modification of my like general kind of coding handle.
I can write it for you.
Yeah, it's PWR. It's just Cell.
Oh, PWR HAUS.
Yep. DACELL.
Is that correct right there?
Yep. That should be it, I believe. And that is my gaming Twitch. I like to kind of throw that out there. It's a lot of fun. The duck, though, says porn it is next time. No. We would think it's very funny.
We're gonna lock that down.
Yeah, we're going to. There probably won't be another next time. That's probably the only time that we'll ever let you guys just hack us. Yeah. So, all right. We have all of this going on. Something that you might be familiar with is fscanf. And so we have a file star, a constant star, and then our buffer. Oh, man. So we're going to do all sorts of things in rewriting this. This takes in our in file.
Says, I do 20% coding, 80% debugging.
Yeah, that sounds about right. That might even be high on the coding. I think I spend most of my time debugging, and I kind of like it. Like, I like the iterative process and kind of like recalling things that I should have known before and stuff like that. I think it's very good to know. I'm trying to think. Oh, a buffer size of 4 is probably not going to work there. We'll say 1024. That also might not work, and I have a inkling of a reason why. Yeah, there we go. I think that's hilarious. So I'm going to stop it from running. I always love when things like that happen because I think that they're actually quite funny. So what I basically did was made a small change, but if you go onto the man page for fscanf, okay, well, my computer has decided to not work anymore. Cool. So we're going to wait while that one catches up to what's going on. If you'd like, you're welcome to take some guesses as to what went on. But basically, the return value of fscanf is not quite the same as the return value for, oh, great. We're going to reopen that. The return value for, what was I using? fread, I believe. And so that is something to kind of keep in mind when you're actually, oh no. Man, live streaming really does kill the ability to type.
It does. Red and Gray, The Duck Though, and Asuna HQ, thank all of you for following.
Yes, thank you very much.
Oh, The Duck Though saying, guys, use size of please, and this non-const int makes my head ache by looking at it.
Yes, so the duck though points out a very good point, which is that I have been using n, and they say non-const int, which basically means that I am using this in order to talk about the size of certain things. And so what they would argue there is that size of for buff would be a better choice, and I very much agree. That actually makes perfect sense. So totally reasonable to do. I would argue in this case it's relatively harmless as far as differences go, but definitely a good idea.
Yeah, the small small optimization, like for smaller programs,
right.
Not necessarily a big deal, but if you're working on a big code base, obviously these kinds of design decisions make sense.
Right, and I think it is actually a good practice to kind of hold yourself to that sort of extensibility problem, where if I were to move this variable to like some sort of configuration file and it's not necessarily immediately accessible, and I used it maybe a bunch of times instead of just one, so in this case I use it twice. Oh, wait, oh, that's a terrible idea. There we go. Then it would actually be much worse to do. I also realized a bunch of you guys are saying you can't find my stream. I might have misspelled it. I will double check on that and get back to you. I don't usually, I don't play any video games when I'm here in college. I only play when I'm back home. So basically, I don't really memorize it super well. But there we go. So now we can go back to what this is actually doing, which is fscanf, or scanf is actually what we're probably going to use. Sorry. Although fscanf in this case. Oh, actually, fscanf works better in this case. I was forgetting that we aren't scanning from a stream. We want to go all the way down to return value, and this will point out to us what's going on exactly with why this doesn't work. I believe it returns null upon reaching EOF, but we will see in a hot second. I always. Well, there we go. Scroll right past it. There we go. So we can actually say, well, that is not equal to EOF. And now we can recompile our program. Sorry, the colors are not quite as pretty. And hopefully cat everything back out. Now, the reason that this is a little bit interesting is that I actually stripped us of our new line. So basically what I ended up doing by putting new line here was I pulled out, oh, I hovered over it so you guys can't see what I'm talking about. I pulled that new line out of the string and then printed it. So that's why you get kind of this weird blend. If I refix that, oh, cool. Then we will end up, oh, maybe I didn't recompile that. I'll clear this. There we go. Oh, well, that's a bummer. Oh, I guess it strips it out on its own. That's kind of good to know. Didn't know that. There we go. Bummer. So that then pulls in the entire buffer. And I guess our buffer is pulling in. Oh, sure. OK. So then it tries to pull in all sorts of interesting things with how it actually decides where a string starts or stops. So we can do stuff like this. And I believe that will fix that error. Maybe not. Just kidding. That's not what that's going to do. Oh, well. So that is kind of the right idea. Someone asks, is that function safe? And what you mean by that, I would assume, is does it protect us from buffer overflows, where we actually insert too much material by a little bit too much into the buffer that we're actually using, and maybe return to some other function start address. And I would argue, I don't believe fscanf is safe, at least not from that. Though there are a lot of functions that are, and it's worth your while to look up which ones are which. I generally forget because I don't build that much in C, but it is worth looking at. And something in general to consider when you're doing, what do you say? If you're doing any sort of like user input interaction, then you want to be very careful of what we would call undefined behavior. So what the duck, though, points out is that this is a straight-up buffer overflow vulnerability. I thoroughly agree. Do not do this in order to interact with anything that is like client-facing. If you're doing it to interact with yourself and it's a small script that you're writing only for your own use, then I would question why you're working in C. But technically, that would be fine. It is something very much you want to keep in mind. And it points to something else that we are kind of seeing here, where spending a lot of time kind of dealing with like how in particular to do each of these things. Sorry, where was I going with that? How to kind of like nitpick and go through each individual piece is very much worthwhile, and you can spend a lot of time kind of really getting into each one of these steps. I would argue that in general, any one of these steps has something about it that we could talk about and maybe optimize or fix. But there is something to be said for balancing it with what you are actually trying to do. And so in our case, we don't necessarily care about how any one of these, I guess it won't really affect our end product, which I forgot where we were headed with that, but that's okay. It's fine. We will now actually talk about making a makefile so that I don't have to keep typing this whole like going up to commands and then rerunning stuff. And that's something that's kind of just worth looking at. And I promised that we would look at a little bit of assembly. So we're going to write a much simpler file that is going to copy things over 1 byte at a time. And that'll give us something a little bit easier to look at as far as what we're dealing with. So what we're actually going to do is rewrite this a little bit. I believe it is just read as the syscall. So this is not using standard I/O. Oh, this is using standard I/O, but it's just read on its own. And I think it takes in a file descriptor, actually. Let me check.
I don't remember. I don't remember if I thanked Ragav Sharma for following, but thank you. If so, if not.
Very cool. So what we're actually going to do is modify this program a little bit in that we're going to deal with syscalls rather than each of these. So we're going to have an int of file descriptor is equal to open of, I think this takes in the same arguments. We'll find out. Man open, man2 open. Path name, cool. And what this is going to do is take in argv1, which we know already exists, and its flags are, oh, right, it takes in int flags. I believe read only. Read only, there we go. Read only. I don't remember where those flags came from. Oh, probably FC and T. Right, that's what someone pointed out earlier.
Flying circles, thank you very much for following.
.h. I believe that has this flag.
It's not underscore.
Read only. Sweet. That is what I like to see. So we're now going to actually open this file and get a file descriptor. Generally, if you wanted to do actual error handling, we are going to like check for return of -1. The standard for system calls is when you have some sort of problem, you return -1. I'm going to kind of omit error handling because I don't want to run out of time and actually talk about each of the things that we want to get through.
Meowcat makes a good point. Syscall being equal to a system call.
Yes, sorry. So yes. Oh, Meowcat. I understand. I was thinking Meowcat. Okay. I think you generally nail the pronunciations a lot better than I do, so I'm gonna go with yours. So yes, Meowcat points out that a system call is the programmatic way in which a computer program requests a service from the kernel of the operating system and is executed on. That is a very good point. And what that ends up actually meaning is. What was I going to say? We have some sort of protected control transfer from user land, which is where all of our processes actually run, into kernel land, or kind of the kernel space, which is scary and all sorts of dangerous things can happen there. You have basically full privilege over a computer. So that's what we're talking about anytime I say system call. And the reason that I want to kind of switch us over into using direct system calls is just so that we can actually see a little bit more low level what's exactly going on using programs like strace and mmap. Otherwise, you wouldn't necessarily need to use any of these unless you were dealing with this particular kind of use case.
The duckbo also just said, pro tip, use mmap. Is that what you just said?
Right. So the duckbo says, pro tip, use mmap. With that syscall, you can directly map the file into memory without needing to read it into a buffer first. That is a great point, although not all files or file descriptors are mmappable. There are some which cannot actually be mmapped into direct, into memory directly, and mmap has some problems that you might have that you might face if you were trying to maybe, for example, implement your own buffering system. So standard I/O uses a buffer cache, which it basically says, and we'll get into that in a second. It allows us to speed up kind of whatever is going on with file read and write or input output, standard I/O, and that buffer cache is I think 4,096 bytes. And what that does is anytime you want to write something to file, it's actually really expensive to write something to a disk directly. And what I mean by expensive is that you have to do some sort of control transfer. I have to give power to the kernel. The kernel's got to save state for whatever was previously running on. And then it's going to actually copy things over into our disk or solid state drive or wherever we are actually storing things. And that's pretty tedious. It's pretty intensive on your kernel. So instead, what happens is before we ever actually pull some sort of protected control transfer and deal in kernel space, we accumulate a bunch of stuff. In the standard I/O case, you actually accumulate 4,096 bytes. And then when you've hit that limit, or when you have kind of closed the file descriptor and you want to get everything out, then it will take that whole buffer and flush it to actual memory. That's for writing. If you're reading, it works kind of the same way, but in reverse, where when I'm reading a bunch of bytes from memory, it actually is to my advantage to read a bunch of them at once, even if I'm reading them one at a time. And we're going to see that in a hot second. Where if I try to read one at a time, I again have to do these protected control transfers back and forth. And so what ends up happening is it's going to be a lot slower if I read one at a time, as opposed to reading everything into a buffer and then pulling it through.
I saw a cool Michael Abrash is a very famous game developer and worked on Quake and Doom in the 90s with id Software. And he wrote a book called I believe it's the Black Art of Graphics Programming, and his first chapter is about optimizing a sort of speller program, kind of like loading a list of words, and instead of loading 8 bytes, loading like 1024 or 2048 bytes at once is like 2 orders of magnitude faster. It was on a DOS platform, and like back in the day, that made a difference between like 1 second and like 30 seconds long for your program running.
That is
it's like exactly
crazy.
what you're talking about. Which I thought
there's enormous performance improvements that can be gained by using buffers efficiently.
Syscalls are expensive is basically the...
Syscalls are very expensive.
Axe Jaw, thank you very much for following as well.
I'll say greater than 0. All right, and then what this should allow us to do is then write, which is also a syscall. I believe it takes a file descriptor, a buffer, and also some size. Okay, this will fail if n is not 1. N in being 1, this is actually okay. But this is okay for us. And then we are going to close file descriptor. Cool. So then what we are also going to do is touch a makefile. And we're going to deal with that makefile. So makefiles are really cool. We're not going to talk about it too much, but I am going to kind of point out what everything does because it'll allow us to simplify some of the other things we're doing. So let's say that we want to just make cat. So this is kind of an interesting, we'll call it like demo cat. That's kind of cool. And that requires, we'll call it cat.c. Oh, no, thank you, autocomplete. And then makefiles, after you give it some sort of like pattern or keyword that it can build, they also require like what command is actually run. So we'll say -o is cat, dash optimized flags we'll set to 1, and then cat.c. And this should be, democat, democat, and democat. That way we can kind of distinguish it from the actual call cat. And then what we can do is also say for clean, I don't know, usually you would remove object files and like other headers and things like that, but we're going to kind of just leave that as very simple. Oh, sorry, remove -rf. We don't need the R, but we need the F. Well, I like having the F there. And cool, so what I can do with this is I do make clean. Democat doesn't exist, but it would have run it. We're also going to move first.c into democat.c. Cool. And we're going to, I guess, remove cat as well, remove first, and remove, actually test.txt is fine. So now if I run make, it should, nice. I have a bunch of implicit declarations of these functions. I really thought they were part of standard library. They might be part of like sys. We'll find out in a second. Let's do man to write. Read would work. It doesn't really matter as long as it tells me which library. Oh, oops, that's a library we need. Where do I want to remove libraries from? Yeah, we don't need a bunch of these libraries now, so we're actually going to kill a bunch of them. I don't think I need those.
Everything breaks.
Yeah, it'll all break now, which is great. Unistd.h, cool. And I believe that has them now. Victorian return value of right, sure.
Brenda was saying that I think she made a reference to using Unistandard earlier. I must have missed that.
That's probably correct, yeah. If you guys brought it up, I'm sure you did. Generally, you guys bring up, oh, where am I missing a return value of right? Am I ignoring it somewhere? Oh, okay, so apparently casting that to void does not work. Sure, I'll use it. There you go. I've used your return value. Cool. And then when we run democat, if I don't pass in a file, it should tell me that I didn't pass in a file. And then I should also be able to pass, test.txt. And it did nothing. Yay! Oh, right. It did actually do something. I just forgot what it was doing. So we read everything, and then we wrote it back out, which is kind of cool. So this actually, interesting. That did something kind of weird.
I read
but
it as
that's okay.
a Democrat.c for a second.
We're running Democrat on its own.
Disco damage, thank you for following.
We're going to actually write fprintf standard out of %s buffer. And that should allow it, oh, oops, not what I wanted. There we go. Democat test.txt. Cool. So we are now catting everything out by one character at a time, which is very interesting. So someone asked, why are we not importing standard library or like standard IO? I think I actually do import both of those, but I'm not using them at the moment. And the reason for that, I actually am using standard IO. Whoops, I needed that. The reason for that is that I want to put us at a slightly lower level than those libraries would put us. Because those libraries have already imported or kind of created their own versions of each of these things. We were using them earlier, where you have like fopen, fclose, things like that. But I'm trying to have us deal a little bit more with like very low level actual, pretty much as close as we can get to syscalls. Sorry. Syscalls themselves. I don't know why I said as close as we can get. This is the closest we can get. They're them. This is exactly what we're talking about. And the reason for that is I want us to be able to see a little bit more about how each of these things actually interact with our computer. So we're going to deal with something called strace. Strace is, I think it stands for like trace syscalls. And we're going to strace.out as our output. And then we're going to run democat, test.txt. And strace is going to write that to strace out. Most of these like beginning ones, you'll see mmap is a syscall that's run up here, and there's a bunch of other stuff. We're going to deal, I think it's like line, oh, there we go. So the first line started
These are all syscalls.
These are all syscalls. Right. Okay. So the cool thing about strace is it actually tells you exactly which parameters were passed to the syscall itself, which is very cool. So, and it tells you its return, which I think is also very cool. So if you're ever debugging something where you're working at a very low level, then this is particularly useful. So what we're looking at is open at, oh, sorry, I'm going to ignore the open. That is technically what our open does, but we're dealing mostly with writes and reads. So our reads here are exactly what are going on. You'll notice that there's this write system call. And if you look in our code, we don't have a write system call. None actually exist. You might think, well, I thought we were talking about only system calls. And I will point us to this function, fprintf, which does not actually explicitly tell us that it uses a syscall. However, in order to write to console, you do actually need a system call. So one of the great inventions of the kind of Linux system is that you have everything as a file and as a file descriptor. So I can describe the console and basically standard in, standard out, standard error, all as files. In fact, they all have their own standard file descriptors. There is a variable, I believe, that is like that particular file descriptor, but we're not going to necessarily deal with that. I happen to know that it's 1 off the top of my head. And so I can actually now write to this file descriptor buff and n.
Well, that's actually what somebody said. The duck, though, wrote that in the chat there.
Oh, nice. Yeah, so if the duck, though, you kind of skipped ahead, I guess, and that's very cool. Yeah, now we can explicitly tell what's going on in our write system call. However, if you'll notice in this original strace out, there's only a single write system call. That's going to change. So what's going to happen is if I recompile this, oh, wait, I have make now. Oh, that's disgusting. What? Gotta love the warning output.
Bavak Knight says, this is starting to get a little overwhelming. What are we trying to do? If you want to maybe reiterate the goal.
Sure. So basically what I'm going to talk about is we are building a version of cat, which is a kind of basic Linux command or bash command that allows us to take a file's input or take a file's contents and just print them out to console. And then what we're going to do from there is see if we can kind of consolidate some of these read and writes a little bit. We're not going to go all the way into that because it would take a little bit too long. But the basic concept is pointing out that what's going on underneath the hood is actually really, really important. And so it's kind of useful to us to see that even though we were working in C, you can go kind of at different degrees of high or low level, even within a language that is notoriously low level.
So taking it from like standard I/O to using syscalls to write, using the kernel,
kind of,
and maybe eventually assembly if you're I'm not sure what your plan is for that.
Exactly. So I mean, I guess to kind of go back to the comment that was libraries are for the weak, we're now basically ignoring standard I/O. However, I am apparently implicitly declaring exit, and I really don't feel like dealing with that, so we're actually going to just switch to return, and that's fine for now. Let's see if. So I'm going to get rid of standard I/O because we don't need that anymore. And that failed. Where do I? Oh, right. This isn't actually going to print anything to us now. It'll just return 1. We're kind of like scrapping a lot of stuff so that things are a little bit cleaner. Ignoring the, okay, sure. So basically, now our code is all system calls, which is kind of interesting. And what we're going to hopefully see is that when we run our code again, our strace output should change. So I'm going to bring us back to this strace output. And what I would like to point out is that hello world got written as one system call, and bye world also got written as one system call of 13 and 11 bytes respectively. However, that's going to now shift because now we write out each individual character. And with a syscall, that means that it has to be done individually. And now we get what we would expect. We get this kind of interleaved read a character, write that character, read a character, write the character, read a character.
Same result, just a lot less efficient.
Exactly. It's so much less efficient. And so if you're wondering, like, oh, why 1? There's actually a standard set of file descriptors for the first couple. The first one is standard input. Standard output. Standard input. I'm doubting myself. Standard input is the first file descriptor, so that's 0. Standard output is 1, and then standard error is 2. And those first 3 are always going to be that way unless you do something crazy. And so that's what we see ending up happening here. Now, something that can be a little bit interesting is if we were to do this on something that's really, really large, then that might actually be kind of problematic because that file is going to be read very, very slowly. So let's say we wanted to cat out using our democat program, something that was extremely large. So let's take a file. Let's do yes, hello, world. Oh, I should put that in quotes. Yes is a program that just repeats things.
Dr. pointed out if we wanted to be clear with the number, we could just use the function file no and take an std out.
Right, file no would also work. And I believe there is actually a library that declares those variables, and it's something like it's like standard out file no, yeah. that would also work. Actually, I would argue that this is a much better system, and generally you'll want to do that. For the same reason that we would use like size of buff instead of n here, although I am using n, and there is no good reason for that at the moment. That's a terrible practice, and I'm not following my own kind of advice. So we will clarify that here.
The duck will be very pleased.
Yes, and I thoroughly agree. So yes, hello world is going to print out a bunch of hello worlds. And what we can do is, let's say into head n 1000, we might need like 10, is that a million? Yeah. We're going to pipe that into our test.txt. Broken pipe, cool. And that makes sense. I generally would recommend using more of a while loop. That's going to be an enormous file. We'll see if it can actually load. Nice. It freaks out. And we should have 1 million lines of hello world. If we scroll all the way down just for funsies, we see we get to 1 million lines of hello world. Yay. So we have now built a test.txt. And if I do democat of test.txt and cat that, or redirect that into dev null, you'll notice that it takes non-zero time. And if we wanted to get like a real metric on that, we could actually time it, which is kind of cool. So we're going to let that run and see what happens.
42 Force, thank you for tuning in. It says hello, Colton Ogden.
Oh, that's awesome. And we go through, and it took us 8 seconds, which is such a pain. If we look at hello world, let's see, HELLO, comma, space, WORLD. I think I have an exclamation point. So we're at 12 right now. Oh, no, I do not. And then we get to 13 as our like size of the string that we have. We repeated a string 1 million times. So we have 13 million bytes in our file.
And they're translating that to 13 million syscalls, right?
Yes, there are 13. Well, so there are actually
new line as well, right?
26 million syscalls. So that included the new line.
Right, the read and
but
write.
we're reading and writing,
yeah.
which is awful. So what we can do is if I actually cat test.txt, which is kind of funny, you'll notice this is noticeably faster. We have exactly 13 million things going on here. We have 13 million characters, which means 13 million bytes for our purposes. And you'll notice cat is substantially faster is an understatement. It's much
Many
faster.
orders of magnitude faster.
Yeah, you can do a basic time on cat, and it's not even close.
Almost zero. Completely zero.
Yeah, for our purposes, it's 0, right? So that's kind of crazy. So what we might want to do is see if we can get a little bit closer to the actual syscall that's going on. And we know through our strace output, that we have this kind of ridiculous interleaving of reads and writes going on, and that's horrifying.
Best OS ever made. Well, not OS, but best system program
Best system program ever made. You get to wait for hours and hours if you want to copy over a reasonable file. So a reasonable suggestion might be, okay, well, let's double the size of this. It should go substantially
Unsigned
faster.
Ed suggested, change your n to be 4096.
Sure. Let's change it to the size of the standard I/O buffer, which is 4096 bytes.
Is that defined as a constant in a library as well?
I believe it is. It is something that is used by standard I/O. We're ignoring the return value of write. We're going to just pretend that that's okay. We would actually make use of these read and write return values if we were to set up our own actual buffer. Now, in this case, it doesn't necessarily matter too much to us, but we will get some garbage output, I believe, if we don't set this perfectly. Like, I think this will actually trigger some weird output, which is fine. So we run make, and everything's up to date. Now, if we run time of democat test into dev null, way faster.
Wow.
Substantially faster.
That's faster than cat, isn't it?
It really is. Yeah, actually, I think it was way faster than
Cat's
cat.
twice.
It's about half as.
You've made a better version of cat. Wow.
Half speedy.
Good job.
Well, so correctness-wise, we're actually not correct.
Okay.
If you were to cat or democat, here we can actually do this. Democat this into test2.txt, and then we do diff of test.txt and test2.txt.
They're not quite the same. Interesting. Yeah, there's an H at the very end by itself.
Yeah, that's a pretty big bummer for us. So that might be something to maybe think about.
The 4096 at the very end, it can't read that 4096 bytes?
So basically it ends up being that, let's say we have 4096, so the nearest multiple of 4096 that's under 13 million. I don't know off the top of my head.
So it just won't call the fractional part at the very end of that.
Right. It'll end up with it'll end up reading all of the bytes. So we know that that part's correct. But what it writes is actually a buffer that has not been cleared. So there is a part of that buffer that has extra bytes in it from before. And that's actually not quite right. So if we look at test2.txt, which is where we actually redirected everything from our demo cat, then if we cat test2.txt, and we can trust that cat is correct, I would argue that you're pretty reasonably there. You'll notice it has some extra lines in it. Because if you cat test.txt, we have exactly 1 million lines. But test2.txt has a couple extra ones. And those extra lines, if we do 55 times 4096, I'll pull out a calculator because my brain is fried. It's been a long day at school, y'all.
If you could do that with normally in your head, that would be pretty.
That'd be pretty cool. I don't think I can. Then basically what you'll end up noticing is that that's around
225,000.
Yeah. So we get 225,000, and that basically means that we are inserting 225,000 extra bytes at the end of our cat program. Not good. Not good at all, actually. And so something else that we could do is, let's say, okay, well, 8092 should be a reasonable next double for our end program, and we can remake. I'm going to just stop searching through history. Remake, it's going to tell us we're ignoring right, and that's fine. And then what I'm going to do is time its output into test2.txt. And this one's actually a little bit slower, which is kind of strange, because I would have thought that as we doubled n over and over again, I should get faster and faster, right? Because my buffer is now enormous. And I'm certainly not below 8092, so I have 13 million bytes in there. So we're not exactly sure what's going on, and we might look to something like strace to find out. So let's go ahead and find my strace, and we're actually going to, test.txt, and I'm going to just wrap that into dev null. Oops, because I don't really feel like having that put out to my screen. So we go into strace.out, and you'll notice that what's going on here is we are doing this explicit write of 8092 bytes every time. And we go all the way through, and that's exactly what's going on. Things are kind of shifting around, and everything's working, seemingly. And if we run this again, but we remake so that we go back down to 4096, and we do make, and run that, and go back here, same thing. No immediate reason as to why we would have something actually be kind of a little bit slower when we ran it with 8096.
Oh, it can't write more than 4096 bytes, because you said that's the max size of the...
That is standard IO's buffer, but we're not using standard IO. We're doing our own system calls. And so this is where kind of one of our professors likes to point this out as kind of a comical point, which is that you should do a lot of trials anytime you run stuff.
I feel like that's science.
Yeah, it's generally kind of a good practice. We might have had just like a weird fluke. So we ran a couple trials. They're all on the order of 0.00567, something like that. So now we've remade this, and we're going to keep running this. And you'll notice this is also that. So then let's double check 4096. And you'll notice that that might have just been a fluke. And actually, it wasn't a fluke. There was something I did kind of deliberately, but very sneakily, that caused that difference. And that difference was that I required the creation of a new file. I did something like test2.txt. And that was that extra overhead. Because when it went to fwrite to something that, or sorry, not fwrite, but when I went to redirect into a file that didn't already exist, it had to create it, had to open it for reading, and for writing, and then it had to send stuff to it. And dev null does not behave that way. So we end up actually being much faster if we're writing to dev null as opposed to this. And that performance change can be seen right there.
Okay.
You get back to that 0.027.
Makes sense.
So actually, in concept, if you went up high enough, this should get very, very fast. Now, you do have a good point in that there is a buffer that eventually this doesn't work for. There is a buffer size in which we eventually overmatch the buffer size.
Is that the amount of addressable memory, or sorry, not the amount of addressable memory? But
that would also be a limit. You can only hold so much in memory.
Does every application gets its own limited amount of memory, right? Or is that only with 32-bit OSs that they have the 2 GB? Because 32-bit operating systems only have 2 GB of addressable memory.
There's actually there's a command to view how much memory is allocatable to any one process. I don't know it off the top of my head. Dang it. There is a command to let you see how much memory any process should be allowed to have. You can up that memory. If you want to be really feisty, you can up it to the entire memory, like the entire installed RAM. Wouldn't recommend, but you could do it. However, you're probably not going to hit that before you hit the size of the other caches between us and the disk. Because the disk itself has a cache that deals with the actual writes to like some spinning hard drive. Okay. And we will generally hit that, but we won't see it in strace. Because strace is just telling us what the actual syscalls are being called as, and we can force it to call them however we'd like. However, there is some point at which you will not get a performance benefit to just doubling this n. So we're going to keep it kind of low at like 4096. But otherwise, that is a very good point.
The doc though was making a point about branch prediction, and I thought branch prediction was in the context of just a single executable, but it looks like they're making a point about it running the same program over and over again. Is that the case where branch prediction will
Right. So that one depends a little bit on who developed your processor, because I have also interacted with them mostly in the case of over one program's runtime, it learns throughout that program. Something that is kind of interesting about branch prediction is it is roughly the problem actually with or the cause of like bugs like Meltdown and Spectre is because branch prediction kind of opened up this opportunity for certain timed hijackings, which is kind of cool. So if you're ever interested, there is a really cool paper on Meltdown, I believe, and it basically walks you through how it's supposed to work. And then I see at the bottom there, ulimit, thank you. I wanted to put uname, and that's not right. Ulimit tells you all sorts of things about how things are supposed to be allocated, and you can set those things.
I've used that to change the number of files that I could have addressed by one process at one time. Or opened, I guess opened by one process at one time. But I didn't realize that it did other things.
Oh, it does all sorts of things. There's crazy amounts of customizability in ulimit. And then there is some discussion in our chat about the kernel being in the stack. That would be kind of an interesting question in that each process gets its own stack, threads have their own stacks, and the kernel has its own stack, and they all live in memory. So stack is actually something that's specific to like a process, roughly speaking. And then the kernel is in the memory, if I'm not mistaken. Yeah, and I mean the kernel's code lives on some sort of disk, unless you are certain operating systems. I believe PyCore and Arch Linux. Maybe, not Arch Linux. There's a different Linux distro that runs entirely out of memory. So in that case, what I said about it living, it's like code living in a disk is not true. However, well, I guess it is kind of true, but like not relevant to the computer. You could run the computer with no hard drive, which is crazy. But yes, everything is technically like, almost everything that you're going to be dealing with is in memory. So, cool. Let's see. There's a bunch of stuff going on in the chat. Always love the discussion.
Yeah, there's a lot. We've been not reading quite as many comments, just so we
can kind of get through some stuff.
Maybe we didn't read quite enough today. ISO TV was saying that they need to leave early, so thanks so much, ISO, for joining us.
Thank you for joining us. Yeah. All right, cool. So we have now written some of this. So maybe we want to implement a little bit of our own kind of buffering system, because we've said that correctness is really not there at the moment. So what we might want to do, and we're going to kind of adjust this a little bit so that maybe our write system calls are all granular, but our read system calls are totally fine. Because, well, actually, we might run out of time before that is even done. So let me think about that. Sure. So we'll do some version of cat that will improve our reading system calls, but not necessarily our write ones. So let's say that we're going to create some sort of new function, int write. We'll say demo write since we're being consistent. And what demo write requires is some sort of int file descriptor as well as some void star. Actually, we'll just say char star buffer and some size t n. And we want it to write out some number of bytes to that file descriptor, but we're going to just have it do that 1 byte at a time. So for int I equals 0, I is less than n, I plus plus. You could do this in one line, but for readability, I'm going to put it all in here. We're going to then call the system call, which is write of file descriptor and buffer, buffer 1, sorry. And this will be buffer at I. So this will write individual characters, and we should be good on that. So let's go ahead and verify that demo write now works. And so this will just, let's see if we can make first. We get some errors. Of course there's errors.
DFL1010, thank you very much for following, or just DFL10 if we're reading it from binary to decimal. I believe 1010 is 10.
1010.
Because it's 2, 8.
2 and 8. Yeah. Oh, huh, funny.
DFL10 then.
Oh, wait, that's kind of great. 10, 10, and 10. Wow, I had never really thought about that.
Now you'll never forget.
Yeah, that's awesome. It's just like something that you don't really think about that often, and.
Duck, though, thanks for tossing in some resources on how OS works. He's talking about BIOS, bootloader, kernel, userland programs.
Oh, that's awesome.
Tossed in a link, osdev.org, it looks like.
Sweet.
Duck, though, sounds like they have a bit of experience with systems and OS programming.
That is fantastic. I think the more experience you get with this sort of thing, the better. Now
I need a bit more. A lot of this is somewhat new. Syscalls aren't new, but a lot of sort of looking at this is interesting.
Oh, that's awesome. So yeah, we have now kind of built demo right. I believe we still ignore that return, but that's fine. I'm really not a huge fan of having warnings, so we're going to just say int r, and then we're going to just cast a void for r. And that's not a great practice for like actual development. Like if you're doing production level development, this would be terrible. But we are kind of just going after the concept, and so it's close enough for what we're trying to do. And now we want to make sure that that actually still works. So let's then just demo cat itself. And we get gibberish.
That's great.
Yeah, that's beautiful. Just go. Let's see what that does. And so this is nothing along the lines of what we want at the end here. That's disgusting. However, the things up here, totally fine.
Is this because you're reading? Are you still reading 4096?
We are,
and the program isn't
this
that long.
program isn't quite
so
that long.
Garbage.
That's all garbage.
Oh, that's memory past the point.
Yeah, exactly. And if we wanted to verify that as far as like what this is, it's only 473 characters.
So we're reading like 3,700 bytes of nonsense.
Exactly. It's just ridiculous amounts of
that's
nonsense.
in different memory. Kailash, thank you very much for following.
So now if we remake this with a slightly smaller buffer size, you'll notice that our gibberish gets smaller. So our hypothesis is probably correct. So then what we're going to want to do is deal with how we actually read things into that buffer. And this is where we're going to want to create a little bit smarter read buffer. So let's do demo.
Are we going to check for end of file? Is that going to be part of this?
Yeah, pretty much. And I mean, basically what we'll end up doing is kind of setting everything at the end, or just kind of initializing the entire buffer to nothing. To 0.
And then just read in only until end of file, and then the rest of it, and then it'll get the null string, and then that means.
Yep, and then we're good. Right. Now, if we wanted to create a really smart read and write, then maybe something that we would do is create a custom data structure in C that keeps track of maybe which file descriptor it's attached to, its own buffer, and which position it's at in the buffer. And actually, you'll find that you require roughly 2 or 3 of those things in order to get that to work. So basically what ends up happening is you need to know where your kind of like imaginary buffer is at the in its beginning and its end. And what I mean by that is it's actually a little strange. You want it to know where it is, like what its positions would be in the file. And so you can actually think about it as like here's your file. If I divide it up into kind of just segments by buffer size, then it makes a lot of sense for me at any time that I'm reading from the file, I read in that entire buffer segment, is what we would probably want to do.
Right.
Now, demo read is actually quite simple. We don't have to do too much with it. But let's say int demo read, and we're going to read from some file, int file descriptor. We're going to want to read into some char star buffer, and we want to read in some number of bytes.
Dr. Sam, let's go lower and create a write kernel driver.
I would argue I don't know how to do that at the moment. It's very possible that one day I will. Very unlikely.
Are you taking CS161, or did you take it?
Yeah, I will be taking that next semester.
They
might actually talk about that.
Yeah, I wonder if you could do that kind of stuff in there.
Which I think is very cool.
CS161 is the operating system class here at Harvard.
Yes. It's a class that I have waited for quite some time to be able to take. Yeah, I've been very excited about taking that. And so what we want demo read to do is actually only read into the buffer some amount of, like, basically whatever it could originally read. So what we might do is some sort of mem set of buffer 0. We'll actually do size of buffer to be consistent. And then what we're going to try and do is read up to n bytes into that. So int r equals read of file descriptor buffer n. And you'll notice this keeps the same usage. And then we might return something r here. If I wanted to be a little bit more concise, then I could return
int in front of n.
Oh, thank you. Yeah. Much appreciated.
Kudos to Duck, though, for pointing that out in the chat.
Nice.
They're on top of it.
Yeah, no, people watching the stream are always very on top of it. It's very cool.
Thank goodness, because otherwise, I know for myself, I miss so much.
Yeah, I miss all sorts of things frequently. Oh, memset is that really a string? I want to argue that there is mem copy. There is a syscall. Oh, no, there isn't. That doesn't make any sense. If you're writing in memory, there is no need for a syscall, of course. And to what I just mumbled to myself is that I was like, oh, there should be a syscall, mem copy or mem set or something. They should be syscalls. But of course, that doesn't make any sense. Syscalls deal with going into the kernel space. And in order to write to RAM, I don't actually need to touch the kernel, which is why it's so fast. So that would have made very little sense, and I'm really glad I noticed that. Cool. So we now are noticing that we still have this kind of problem of gibberish at the very end. And that's something that's totally reasonable for us to expect, in that we did do actually a mem set of size of the buffer into 0, blah, blah, blah. However, something that we might want to do is something more like this. So what we will do is we can capture this output from demo read and use that. And so what we can say is something like this. While true, and we'll break out of this using break. While true, int r equals demo read of standard. Oh, wait, no, we're using file descriptor. Buffer size and size of buffer. Now this return from demo read is the same as the return from read, which is how many bytes we actually ended up reading. And so what we might do is something like demo write of actually just r. And from there, if r is less than or equal to 0, then we break out of this loop.
You don't have access to true either, by the way, because you're not including standard bool.
Oh, awesome. Gotta love that.
While one.
A lot of these sorts of things, I would argue, are not great, and so it is our job to point them out to you. This is an example of something that is not the best design.
You see it everywhere in like the 90s and 80s, though.
I know, and that's the part that astonishes me, is that that worked. And you'll notice that this now does exactly what we would think, where it actually cats the right thing out. If we wanted to verify that, test.txt to test2.txt, we can go ahead and do that. This will take a little while, probably up to 8 seconds or so.
Davin's LMAO, what are booleans in 2019?
No need for booleans. You just use 1 and 0. Or, I mean, if you're even crazier, maybe you could find a way to use like empty string or like an empty list and like, I'm trying to think of something creative, and like the number 42 as true. You know, like you could do some pretty weird things.
So what was this? So R is going to be, so you were breaking if R is less than or equal to 0. So in which case is that going to be the case?
So that will occur anytime that there is an error in demo read or when we get to end of file.
Okay.
And so both of those mean that we break out of this while loop and then close our file descriptor and exit.
And then demo read's not going to read the full 4096 bytes if it's at the end and it goes beyond 4096?
Right. It'll read up to 4096 bytes.
And that's up in demo read. Can we see which part of that?
Exactly. So if we go into demo read, we are setting our entire buffer to 0, which is actually not necessary at the moment, but I had it there originally. And what this does is we actually do some sort of int r equals the read of our file descriptor that we pass it into the buffer up to n bytes.
Right, okay.
And that's what we're looking for. And it returns up to n, or -1 if there was an error.
Okay. And then so the actual function call of it, we're reading this, 1024. Okay.
Right.
And then, okay, I got it.
Yeah, exactly. And so you'll notice that program to kind of cat everything into test2.txt took quite some time. And so we're going to strace one more time, that, and see what happens. Because that is a little bit strange. Excuse me. And if you are kind of looking at these and you're saying, oh, well, obviously this would have some sort of weird output, it would take a very long time, you'd be very right. It is quite obvious if you can remember. If you scroll up to demo write, we write everything 1 byte at a time. And that is where you actually see this get quite slow. Now, if you'll recall, our original program that read and wrote everything 1 byte at a time, that was 8 seconds or so. This one does not seem to be only 8 seconds. It takes quite some time.
Quite a tremendous amount of time.
And we're going to kind of, strace out is going to be quite large in the sense that we are reading and writing 13 million lines. Now you'll notice we did this read of 1024. That was great. And then we proceeded to write 1,024 times, which is a huge pain. So if we wanted to speed things up a little bit, then we could still increase this buffer size of ours to 4096. And we could do this. Oh, wait, I have to remake. We go through, and it will get slightly faster. Now, strace is going, I shouldn't run that with strace. What I actually wanted to run was this to kind of point out to us just how much faster it got. Now, this should be some weird hybrid of 8 seconds and 0.0015 seconds. Now, we might end up with something a little bit different from that. We could hypothesize as to why that's true. And then the next step would obviously be to write a write buffer, which is a little bit different in that whenever you go to close the file, you also need to flush the buffer to the file. And that would require a little bit more kind of work on our part. I guess I could have actually had that be our goal the whole way. But we have now, at this point in time, talked about how to build a kind of version of cat using standard in and out, standard I/O. And that's kind of cool. It doesn't have all the features and functionality of cat, but it does work. And then we went and moved to something that is a little bit of a hybrid between low-level syscalls and standard I/O. And then we went all the way into a syscall version of cat that has some of its features in that it can read pretty quickly. It has a buffered read, but its writing is pretty terrible. And so that is something that you might be interested in exploring a little bit more. It's very much a worthwhile exercise to see if you can implement different kinds of buffer as opposed to the one we're doing here, which would roughly translate to a single slot buffer. We have a single slot that we are using to build or to read into and then write out of. However, we could very easily build a multi-slot buffer where I read into one slot and then into another and then maybe up to 4 or more, and maybe have some reason and policy by which we kick something out of a slot and fill it with a new set of data. There's all sorts of things you can do with that, and I would certainly recommend trying out all sorts of things with how you actually deal with kind of how your computer runs. Cool. I think it's very cool. So that concludes all that I have as far as the stream goes, actually.
Thanks. Yeah, we are at the 2-hour and 10-minute mark. So thanks everybody who came in today to check out the stream. I'm going to take us to the wide shot. Actually, no, screensaver. We got to do the screensaver. That's the
that is very important.
We've taken it out with that every time. We'll leave it on this for just a minute. while we take some last questions. So apologize if we didn't get everybody's questions today. There was a lot, which is awesome. I really appreciate everybody's involvement today, everybody tuning in, and a lot of people tuned in really early too.
Yeah,
which
that
is
was
awesome. Join us for the next one. Actually, I'm curious. It's the end of the semester here, coming up pretty soon. This might actually be the last stream until 2019, which is kind of ridiculous.
That's crazy.
Yeah, we have the fair this week, and then next week is everybody's leaving. I'm leaving town, actually. I'm going to California.
Hey.
And you're from California, so you'll be going to California.
I'll be going to California, too.
Nick and I are going to California. I don't have a streaming setup over there, so we might not have another stream until 2019, but if that's the case, it'll be January 2nd or 3rd probably, and then we'll be sort of doing weekly streams, like multiple times per week going after that. You'll be part of that, I presume.
Yeah. No, I will certainly be there. We have like Raspberry Pis coming up.
Raspberry Pi.
We'll deal with some like hardware stuff, maybe even get a camera on one. We'll have, I think, Kali Linux will be coming up.
Yeah, the
a
white
CTF, live CTF going on. We will have, I don't know if, did David do a Docker one? Yes.
He's going to do a Docker one.
Okay.
Yeah, he wants to do a Docker one.
That one will be there. We have all sorts of things coming up. Oh, Bitcoin. We'll talk about.
True.
We'll talk about Bitcoin, and I guess we'll lump blockchain into that, just because that's also very interesting. Maybe like an API build, like build a RESTful API.
A RESTful API would be
kind of cool.
Yeah, get the web devs.
All of our web devs will be happy. You know. We might even build a Swift app.
A Swift app would be
I think that'd be really cool. I thought about, I had totally forgotten about that until the CS50 hackathon. And then everyone was like, oh, Swift, I love Swift. And I don't really like Swift that much, but I do love building apps in it, and I think that's really cool. So I think that'd be pretty fun.
Yeah, all of the above, all the things.
Yeah, we'll go and build all sorts of things.
Yeah, no, we have a lot coming in, and then I have, we'll be doing probably once or twice a week gaming related, game programming tutorials and streams. So tune in for those. So starting around January 2nd or 3rd, and then I'll get in touch with you to figure out what the first day will be. We'll be on the Facebook group, so definitely message us. If we don't see you or hear from you until then, we'll definitely have a great holiday yourself. Yeah. Wherever you are in the world, and whatever holiday you might be celebrating this
People
December.
are all over the place. That's awesome.
We've got people from all over the world, United States, and then abroad. We have India, we have Italy, Greece, and all sorts of places. New Zealand, Brenda repping New Zealand is a big one.
Literally all over the world.
Belgium, Netherlands, all kinds of places. Lots of great messages in the chat saying have a great,
you guys so much.
great holidays. Yes, same to all of you.
Yes.
Bavik Knight, Meowcat, 42 Force, Irene, 42 Anto 42, Unsigned Ed. Shane Hughes, 1972. California. Says California.
Me too. Yeah.
California is good stuff. California is good stuff. And then Asley, Andre, Fatma. Yeah.
Thank you guys very much.
It's going to be...
oh, shoot. I forgot that someone in the chat said, what did you do in binary exploitation? And I totally forgot to talk about binary functions and things. We'll mention that. We'll do a whole stream on it.
We could do a part 2. We'll do a part 2 maybe on that. There's just so many things to cover. So much to cover. Yeah. And 2 hours is not a lot of time for all this stuff. But yeah, thanks everybody again so much. This has been CS50 on Twitch with Nick Wong. My name is Colton Ogden, and tune in next time. Tune in January if we don't do another stream until then. And have an awesome holiday season.
Yeah.
All right.
Enjoy. See you guys.
Happy holidays from CS50.